This is section 7.7 notes day 2. Today we're going to be talking about exponential decay. So yesterday we talked about growth, today we're going to be talking about decay. Now decay happens in a graph when you start up at a really high positive number and it gradually gets lower and comes towards 0. It also works negatively, so it could go way negative and it just comes up and gets really close to 0. So either one, positive decay or negative decay, it's still a decay because it's coming and ending near 0. So how do I know if an equation or a graph is decay? Well, if I look at an equation, I'm going to have y equals a times b to the x exponent. So this is the same equation as before, but the base number is going to be the decay factor, which means it should be a fraction or a decimal less than 1. So some examples are y equals 4 times 1/2 to the x power. 1/2 is less than 1. Y equals 1/2 times 0.35 to the x power. The 0.35 is less than 1. Or something like y equals, in parentheses, 4/5 to the x power. 4/5 again is less than 1, so it's going to be a decay. The initial amount, the amount that you start off with, does not matter. It doesn't make it a growth or decay. It's all about the number that's attached to the exponent. So how do we use exponential decay? Well, we're going to go through problem number 1 and label your initial amount, your decay factor, and your exponent. So it says the atmospheric pressure at sea level is 101 kilopascals. That's your initial amount. Every 1,000-yard increment in altitude, the pressure decreases about 11.5%.
Keegan Klinger, please come to the office. Keegan Klinger.
Write an exponential decay equation to model this solution. So, step 1, what is the initial amount? Well, that's 101 kilopascals. Step 2, what is the growth factor as a decimal? So that's your percentage. It's 11.5%. But it wants it as a decimal, so I have to move this decimal place 2 places. So it'll be 0.115. That's 11.5% as a decimal. Step 3, since the decay factor must be smaller than 0, or smaller than 1, we need to subtract this decimal from 1. Just like yesterday, the amount needed to be greater than 1, so we added 1. Today we're going to subtract from 1, because it has to be smaller than 1. So this guarantees that it's going to be smaller than 1. So 1 minus 0.115 is 0.885. Okay, so this is really our decay factor. So now I just need to write out the equation. So it starts with y equals my initial amount of 101 times my decay factor, 0.885 to the x exponent. Because remember, the decay factor is the base number, so it has to have that x exponent on it. Okay, so problem number 2 is going to combine what we did yesterday with what we did today. We're going to state whether the equations represent exponential growth, exponential decay, or neither. So in order for it to be growth, the number with the exponent has to be greater than 1. For it to be exponential decay, it has to be less than 1. Or neither, it's either going to be exactly 1 or it's going to be something like a letter or variable. So, for problem A, y equals 0.93 times 2 to the x power. I'm just looking at this 2. Is that greater than 1, less than 1, or neither? 2 is greater than 1, so this will be a growth, exponential growth. B, y equals 68 times x squared. Well, the base part is a variable. Is that greater than 1, less than 1, or neither? Well, because it's not even a number, it's going to be neither. Letter C, y equals 68 times 0.75 to the second power. This part that has the exponent on it is going to be 0.75, which is less than 1. So that'll be a decay factor. Now looking at graphs, I want to see curves. I don't want to see lines. I don't want to see U's. I don't want to see V's. I want to see curves. So here I do see a nice curve. It starts way up high and goes down towards 0. Because it's coming and it's ending near 0 here, that's going to be a decay. Because it's ending near 0, going towards 0. Now, for E, it's starting near 0 and it's going up really, really high away from 0. That's going to be growth. It's still that nice curve, but it's starting at 0 and it's growing really, really tall. F is a U shape, so it comes down towards 0, but then it goes back up. So this is neither.